Hi, my name is Nadav Iron, and I'm the VP of Engineering for Google's ML infrastructure products. Our mission is to drive ML excellence for Google and the world. We create the tools, frameworks, languages, and services to power Google's AI-first strategy, and we make them accessible to all of you, so you can build the things that you care about. So let's start with what we've been working on with machine learning at Google. ML powers amazing things, from night sight in pixel to reconstructing thousands of particles in one go at the CERN Large Hadron Collider with TensorFlow. While it may feel like magic at times, it's simply advanced technology, made possible by tools that are easy to learn and use to solve your own problems. The goal of any platform is to let you build solutions to your problems, and we're working to build one for machine learning that can be used in your business, your hobby, or even cutting-edge research. When building ML solutions, you work with data, with ML models, with conversion to different runtimes, with optimization, deployment, MLOps, and a whole lot more. So let's take a look at some of the major parts of the ecosystem, like TensorFlow. We open source TensorFlow to accelerate machine learning research and empower developers around the world to build AI applications. That was 6 years ago today, and we're so happy to celebrate TensorFlow's birthday with you all. TensorFlow has expanded into a vast ecosystem of tools and frameworks that help you along your developer journey. Let's take a closer look at the ecosystem, starting with Applied ML. We'll start with the tools we have to go from data to production. From your first and simplest Hello World machine learning model, you can use the high-level APIs from Keras. The same skills will transfer to more cutting-edge problems. We often hear that machine learning models can be opaque, and we'd like to understand how, for example, a computer vision model determines what it sees. With research into class activation maps, there are techniques to see what the model pays attention to. So here you can see simple Keras code that shows us which part of the image the model paid attention to when it classified a cat. It was the cat's face. Because of how it can be used in problems, from the simple learning one to the more complex research-oriented ones, as I just showed, we believe that Keras is the best framework in the world for applied AI. And it's our primary high-level API for developers using TensorFlow. It's not just for getting started. Let's look at some of the new advancements. In TF 2.4, multi-worker mirror strategy was released. Keras models now support training on TPUs, GPUs, multi-GPU machines, or clusters of multi-GPU machines by simply switching their distribution strategy between TPU strategy, mirror strategy, and multi-worker mirror strategy. In TF 2.4 as well, the Keras Mixed Precision API was released, allowing faster training on GPUs in float 16 mode, as well as bfloat 16 memory optimizations on TPU, with automatic loss scaling. In TensorFlow 2.6, Keras preprocessing layers were released, making it much easier to add preprocessing capabilities to your models. They had multiple preprocessing layers for categorical data, replacing the feature columns API from TensorFlow 1. Preprocessing layers also add a new comprehensive text vectorization layer that will make your NLP models much more readable. Additionally, as of TF 2.6, Keras has been modularized as a separate pip package on top of TensorFlow, installed by default when you install TensorFlow, and now lives in a separate GitHub repository at the link shown. This will make it much easier for the community to contribute to the development of Keras, and we welcome your PRs. And we know that as developers, efficient problem solving doesn't equate to building all your models from scratch. Discovering these models and how to use them isn't always easy. And with that in mind, we created TensorFlow Hub. On TensorFlow Hub, you can find hundreds of pre-trained models for video, image, text, speech, and audio. For example, here's a simple model we trained for comment spam detection. You can find it in Hub and then test it easily. Or this bird detection model where we can upload a picture and get it classified. And of course, when you want to use the model to solve your business problem, you don't have to do it by yourself. TF Hub will show you how to do it, which layers to freeze and which ones to use for activations, etc. We just saw a browser-based tester for models with the comment spam and image classification. And think about that. It was a model running in the browser, which means anyone, anywhere, can try your research with a click of a link. No dependencies to install or environment to set up, and usable by billions of people around the world. This is powered by TensorFlow.js, our JavaScript implementation of TensorFlow that enables you to run or train models anywhere JavaScript can run, which is pretty much everywhere. JavaScript can run in the web browser, on device, server-side, native applications on both mobile and desktop, and even IoT devices like a Raspberry Pi. As such, TensorFlow.js has seen enormous growth in the last few years. You're not limited to just running models in JavaScript. You can also train them too. And we've designed the APIs to be very similar to the Keras Layers API you saw earlier, so your knowledge in model architecture design and programming skills can be reused within the browser. We also make use of the GPU where appropriate to speed up training and inference in the browser. We see a lot of companies using TFJS in production. For example, Include Health use it to enable remote physiotherapy at scale while maintaining the user's privacy. Here, we see MoveNet's single-person detection model. We also just recently launched a new multi-person detection model of MoveNet. This model can not only detect multiple people, but also track their movements. As shown here, even if two people exchange positions, the model can still identify whether the person who moved positions is the same person. For more inspiration, check out what the TensorFlow.js community has made by searching hashtag #MadeWithTFJS on social media. We've just seen deployment of models to the browser, but of course, there are many other places you can deploy them, such as to mobile devices. We're going to continue to see ML move from a niche market to being the building block of everything we do. And I believe Google is on the path to delivering the technology that will shape so many products and research in the future.
Ini untukmu yang selalu memancarkan sinar dan jeli melihat sisi terbaik dari segalanya. Buat semua mata tertuju padamu. Jangan berhenti melihat lebih jauh dan dengarkan keindahan dunia. Bersiap hadapi perubahan. Cepat menyesuaikan langkah. Jadilah spotlight di sepanjang jalan yang kau tentukan. Hyundai Creta, Spotlight in Motion. Book now.
Cukup satu paket akrab untuk internetan sekeluarga. Coba deh.